Okay, so in the classroom there are some files that we will use, so you can download it. So I'm starting to open the terminal for running Python. Okay, so to work with numerical calculation, we have to use arrays instead of lists. We have seen that. The Numpy library contains function and method to create arrays besides some utilities to work with random number, let's square fitting and minimal. So let's see what are the most important ones. So now let's start with our terminal with IPython and create these three arrays. Okay, this is the first one. You can see the two first has the same length, but the third has only two elements. Okay? Let's create these three. That is not important the number here, right? So you can type any float, but be aware that the first two must be 6 length number. And
this the syntax.
Oh, because we have imported everything. Now, import here, and in some moment the upload library to plot to make a very simple plot. Now we are going to import everything like this, okay? From Numpy import everything which is the asterisk. So we don't have to type NP or whatever Numpy every time, okay? Because we are going to work only with Numpy today. So let's type these three arrays, and let's make some operations. Everything is able to create the arrays. Something? Okay. And Numpy. So first. Oh, you are okay. Yeah, comma. No. Wait, but we are going to use first. Okay. No, asterisk. From Numpy import everything. From Numpy import everything. So we don't need to. That means that we are going to import all the functions without any error. And now you can create A, B, C. That enter there. Okay. So it is not important. It's important that it's not the important number, but try to introduce a 0 in the second one, so we can see how Numpy handle the division by 0. Okay, so are all we in the same page with the three arrays? So now we have the operation is very simple, but it's made element by element in Numpy. So if we divide A by C, we are dividing the first one by the first, the second by the second, and so on. Okay? So we can print the first one result, C1. As you can see, there are some. Numpy can divide by 0, can handle that, and assign an infinite or an odd number that depends on the operation. Okay? For example, we make the second operation, which is the square root. It's make also. There should be a warning there because we are taking the square root of a negative number, and should say it's not a number, but it's there. So that the code doesn't break, but it puts not a number in there. Okay. So are we all okay? Okay. So all have the three arrays. Okay. Do we have the operation right now? Okay. So we can remember that list can be concatenated, but and also we can do this in the same way we can do this with Numpy. So we can concatenate arrays by using concatenate. So we will want to add together B and C. We use concatenate, and this create a new list, which is the both together, A and B.
Why do we need two braces?
Oh, because the input for concatenate is a tuple.
Ah, okay.
So it expects a tuple. And a tuple is between the parentheses. Okay. So let's create a new array, which is the join of B and C. We can do that, and or we can concatenate add a single number to a list. But because this is expecting not a single number, but at least we should keep between brackets if we want to add just a single number. Okay? It's working?
Yes.
Okay. So let's continue. We saw that we can mix numbers and strings in Numpy. Now let's concatenate two different lists, one of number and another with string, and see what is the output. So remember, to concatenate is a tuple, and the first one is an array of number, and the second one a list of number, and the second one a list of strings. What is the output? What type of element are strings? Yeah, so when we concatenate number and string, the final result is a string. Okay. We can use insert to place a specific number in some place in our list. So let's insert one specific number, this number, in this list at this position. This position is the index, right? So it will be in the second column because the first index is 0, the first column is 0. So let's do it and see what is the output.
So you add to the C at the first position, the second position, the index 1, the value minus.
That's right. So this is where we want to insert this number at this index.
Okay.
Okay. Is it working? So now we can see if that is okay. It has been done by printing theta 6. That should be exactly like this, but plus one number which is in the second column should be there. This also works with list of elements. So let's say that instead of a number, we want to introduce several of them in a specific position. So let's say that we want to insert in our list, our array B, in position, in index 2, 4, and minus 1, these numbers. Okay? Let's do it.
I forgot the laptop at home, so.
Oh, okay. So you cannot run IPython?
Yeah.
No, you can't.
I can't.
Okay.
But I
So
also do.
you can go to a web page. You can run, which it's called Python.
Only for link to
Python, yeah. So you can run in the web in a website Python code directly.
when I want to to go to classroom page, but there's a lot of time that
Okay,
it's
but
thinking.
one question,
What
but
about-
you cannot run IPython now
No,
there.
no.
But you can open a new tab there and go to a web page where you can run Python without needed of have Python installed.
Okay.
Right? Python, Python ja. Python WA all together. No, W. Come si chiama? Y. A. No, con la A. Come si chiama? Python già?
Se cerchi Python Anywhere o qualcosa
Anywhere,
del genere, lo trovi. Cerca Python Anywhere e ti apre una console dove puoi lavorare.
Il problema è che in Gmail sono 10 minuti che sta ragionando su
Sì, vabbè, però se tu apri un browser
Sì.
and you type pythonanywhere.com però il browser quando switcherà
sì, no. Please, thank you.
Okay, so if we open just a number, it's at the end, like in the list. Okay, if we type appends our array and the number, this number is going to be added at the end of the zero. Okay.
But the example Z7, no? You are including the same three number? No,
This
the
one.
example before. The same
One.
Okay.
No, these three numbers at
in
position
2,
2,
4, and minus
4,
Okay.
and minus 1, which is the last one.
Okay.
Okay.
Is it possible to in the same string, cioè with the same command, to put different number at different position in the
Like this different number at different positions.
It's not repeated.
No, it's minus 1.2, 5,
5,
5.
6, 4.
So
Okay.
it's three different numbers.
Okay. Position different.
These are the numbers, and these are the position.
Okay.
The first list is
Okay,
the
okay.
position, the second the number. Okay.
So how can you work with a -1 position?
Minus 1 is always at the end. Minus 2 is 1 before the end, and so on.
Penultima.
Sì.
Conto dall'inizio, conto dalla fine.
It doesn't matter. So this is very interesting because it doesn't matter how long is. So you don't need to calculate the long of the array. Just you say at the -1, and it goes to the last position. Okay. Okay. So let's use very useful mathematical operation. Remember the point when we saw the last day the class associated. So the method associated to an object can be called with the point. This is a good example for example. So now for this array Z7 is an object and has some method with punti tabulation show all the method. One of them is calculate the mean, but also we can use in this way or directly the function mean, and here Z7. It will show you the mean of the values in that array. Okay. So let's try with median. This is median is not a method of the array, so we should use this function directly.
Why not?
I don't know. Probably because if you want only one element, it makes no sense. The median. I don't know why it's not, but it's something of the programmer of Python decide not to include. So in this case,
the
median must be called in this way.
If we imported Numpy as NP,
NP.
then the NP median.
No, this is all we work.
This will work in any case.
In any case, because it's a method associated to the object. But in those cases, you should add NP always.
But the mean in that case, Z7 don't mean.
the mean is taken from Numpy. It's not a system.
From Numpy.
It's
No,
still
no.
Numpy.
Because when we create theta 7 as a Numpy array,
It knows
all
that.
the method has been associated to
Okay.
that.
So it's not. I don't know if we have loaded I don't know ShiPy. No.
No, it's
The
not.
me-
This
the
mean is always associated to the way you have created this one.
So if I generate the array with Numpy as a Numpy array,
Only have method of Numpy, not
Okay.
Stippy.
you can generate arrays also with ShiPython or
No, but you can create different. Sometimes you can create, for example,
So you know that if you generate some arrays, some
the
whatever,
method is for that.
with a given
The library
library, yes, then the methods you apply
is for that
are
library.
from that library.
Yes,
Okay.
that's right. So we can calculate the minimum, maximum value, the sum of all element, the cumulative sum, the standard deviation, the absolute number. This is also a function. It's not a method of the object. But we can calculate what is the location of the maximum index, the maximum value, or the location of the mean, or just sort the array. Notice that this modifies the array. If we apply this, it's going to modify this one. Okay, so be careful with that.
If I have an array of arrays, it sorts everything.
It's
with respect-
complicated because you have to say what access should be used for that.
But then everything is sorted accordingly.
Yeah. So try those ones and see how with sort you modify theta 7.
And how do I know the arguments of those? Just
Which argument?
for example, I want to sort in the inverse direction.
Okay,
So how do I know?
yes.
Question mark. How do I know?
Yes, question mark sort show you destin, astin.
Where do I put it? Because it doesn't work.
Yes, no, you sort question mark.
Okay.
And also could sort also strings in alphabetic order.
Okay.
So it works also for strings. Okay?
Mm-hmm.
So it's okay? Okay?
Just a question.
It's working.
What is the reason for which there are two different commands for doing the same thing? So theta 7 point mean and median.
No, this
No,
is,
sorry,
no.
mean.
For example,
theta 7,
mean
theta 7.
using this way and also mean as a function.
Okay.
Because we saw the other day that when you create an object, this theta 7 is not an array, but is an object that has been created with Numpy. Numpy sum, in the way that internally work Python is with classes. And you create an object and all the method and function associated to that object is attached to that object. Because we have created this with Numpy, all the methods are working with that. But suppose that you don't have created an object with Numpy. For example, just directly you want to calculate the mean of something, right, of two numbers. So directly you put here max in bracket. The thing that is within the brackets could be anything that you have created without Numpy. Okay. Okay. So if we use mean in theta 1 and theta 2, it will give not the mean, but infinite or none number, because it contains none and infinite. So for those cases, in those arrays that contain this thing, we can use a very interesting function, which is none, mean, max, mean, or standard deviation. So we take out all these numbers, the none number, and show the computation of the mean or max without taking account not numbers. Okay? Removing none from there. This works only for nuns, but not with infinite, because there are two different things. If we want to remove infinite and take the mean, we can use, for example, this function will show you if what is the position of the infinite element in an array. So if we say, if we can play with this, we can type isInf of this one, and it will show true or false depending if the element is infinite or not. Okay. With this, we are taking the negation of that. So at the end, this, which is the, I don't know, the virgoletta, ¿cómo se dice? Tilde, we're taking the elements that are not infinite. Okay? So this is a list of false or true elements, a Boolean list. So this Boolean list we can use with our array to remove the infinite elements. Okay? Is it working? No. So this will work if zeta 2 has none number. Even if they don't have, they should work. Okay?
Okay. Yeah.
Yes. And now, zeta 1 should contain infinite, right?
Yeah.
So if zeta 1 contains infinite, is inf just right there like that, infinite.
And what is the meaning of the tilde again?
Because is inf say, okay, those elements are infinite, but you don't want the infinite. You want the opposite. So
okay,
it's
so
like multiply
like,
minus 1.
Okay.
So it takes the same.
It's removing the infinite.
Removing no, changing true to false and false to true.
Okay.
That is what is the negation.
Okay. Oh, so the tilde is the
negation. It's like multiply minus 1 also. If you multiply the output for minus 1, you convert true to false and false to true. Okay? And then you can compute the mean. And do you obtain a result, a good result? No? No there? Okay, what's it there?
It can't read the tilde.
No, because the tilde is operating on is in here, inside. There.
Ah,
Okay? Adriano?
Non trovo la tilde sulla
It's like around here. Con al graph.
perché queste
No, I think la tilde is usually here, right?
però con queste non va.
Io non è che c'è la tilde alta, sai?
no, sono tutte tilde.
C'è la tilde alta.
Con questo non va, alt sempre no.
Che non so neanche che esiste. La tilde alta.
Non ha capito.
Ce lo cerchiamo.
Okay.
Non emotico neanche nei caratteri.
Okay, let's go. So, for example, if we want to get some index, we can use expressions like true or false expression. For example, get index that follow a condition, we use where. And it's going to give not false or true, but the index where the condition is fulfilled. For example, where are located the elements smaller than 0? We show index.
Ah, okay.
Okay? So there are a large number of trigonometric functions, logarithm, square root, some, for example, like this. A lot of them, hundreds of them. Also to deal with degrees, radian, this is to convert to radian, this is to degrees, and this is to convert to radian to degrees, so on. Okay? And the constant pi and e.
The fault is in radians, right?
The fold in actually the arguments of the trigonometric function are always in radian. okay, Numpy contains also function to generate random number for different distribution. Here I'm showing you 3 of them, which is the uniform, the normal or Gaussian distribution, and the this one which is the uniform integer. Okay, so this is float. The uniform are float. So usually the call of this function is random. If you type random point and tabulation, you will see how many distribution you can work with. Okay, let's try to generate a bunch 100 numbers for the uniform distribution with lower number minus 1.2 and high number 3.4. Okay, so let's do that and see what is the output.
I can put this in an array. For instance, I can define.
This is the if you put size equal 100, it will give you 100 number. If you put a tuple instead of a number, it will generate 3 by 4 number. Okay.
But if you write A uguale, then it goes in an array.
You want to generate just one number, you don't need to give size. Without size, generate just one random number of the distribution that you have selected.
What is the seed of the distribution? Do you give a seed?
You can place a seed. Also.
You cannot.
You can place a seed. Enough it take one random internal one which is generated with some algorithm, but you can place a seed, so you always generate the.
If I do two subsequent,
it's different.
They are different.
It's different because the seed is.
If I give the same seed,
it's the same distribution. So every time it's the same distribution. Every time you run this, is generate a seed, a different seed. So you can say that these two times that you have running the code is a different, the parent distribution is different. But if you use a seed, you are taking random number exactly of the same parent distribution with the same seed. Okay, so let's say we have a parent distribution which is determined by the parameters of the distribution. Let's say a Gaussian. A parent distribution is an infinite number with a location and a sigma, a mu, a sigma. Okay, that's the parent distribution. So if you can take one number, one random number of that distribution every time for the same distribution. Okay, the same distribution, and this is done if you set up the same seed, okay? The same seed. So every time that you run the normal, you call the normal, the seed is changing. So it's not guaranteed that it's the same distribution because the seed is completely different, okay? If you set up the seed, the distribution, the parent distribution where you are taking the number is exactly the same always, okay? So if you want, actually, for a random distribution, you don't need to change the seed. You don't need to fix the seed. Only if you want to be sure that the distribution where you are taking the random number is exactly the same. Exactly the same. I mean, the location and the sigma is always fixed with these parameters, but doesn't mean that it's the same distribution. Okay. In the parent distribution, only God knows that what is the parent distribution. It's infinite number, so okay. So you can fix usually you don't need to fix the seed because internally this is handled pretty well. So let's try with a normal one. In this case, we have a different parameter, which is the location, which is the mu, and the scale and size. This is a Gaussian distribution or normal random distribution. Or a random uniform of integers. Now we give low and high, that should be integer. And here we can say, okay, we want an array of 3 by 4. That's the size. Is it working?
So it is a matrix.
It's a matrix, 3 rows and 4 columns.
We only took 12 numbers.
define it.
12 number, yes. So you will have 12 number arranged in this way. Is it clear how it works? Anna?
If I want to know, receive an help about the possible distribution, it's enough that I type
Random question mark. Random question mark. Or for a specific distribution, random point, normal question mark.
And these are function intrinsic in...
Yes, it's built. Most of the 99% of the function of Python is built in C, using C. So are very fast. So are called to some C function that are compiled. So this is because these are very fast. The built-in function of Python are built in the C language. Okay, let's go to multidimensional arrays. So we have seen something about this last day. So we can create a 3x3 array by using nested list. So we say array, so within the array function we set 3 separated lists of 3 elements each one. This will create a 3x3 array, no matrix. Don't confuse with matrix, because when we multiply this array by a number, it's not multiplied in a matrix way, it's multiplied element by element, okay? We will see how to work with matrix. Now, those are arrays. Or we can create also just giving all the numbers in one list, and at the end the side with reshape. So with reshape we say, okay, those are my numbers, and I want at the end a tuple of the size of the element. In this case, 3x3. Is it working?
Mm-hmm.
Adriano, is it working? Bene? Good. So we have also very interesting arrays which create all zeros or ones, which is called zeros or one, and we have to give inside a tuple with the size of the array. 3x6, 3 rows, 6 columns of 0, or 7 rows and 4 columns of 1. Okay? Zeros and ones. So how can we access? Usually in the same way that we saw with the list, just with index. The first index is the row and the second the column. So we have seen that the multiplication with multiply one array by an element, the multiplication is element by element. So we can create an array all elements of -2. All elements of -2. It will be -2 times an array of ones, the 3x3. So the result will be all elements -2.
Okay.
And now we can create a new array by multiplying the same this one by this one. Both arrays must have the same number of columns and rows, because the multiplication is element by element. Okay?
So each array of one element.
This one this multiplication is going to the first element and multiplied by the first element of the other array. Go to the second element, and so on.
Okay.
Element in the same position.
Okay.
So if you try to multiply two arrays of different size,
It's an error.
it's an error. You can multiply an array by a number. Okay, that's okay. but not for another array with a different size.
You can use normal trigonometric or whatever function.
Whatever form, whatever thing.
Yeah.
Even you can create arrays of strings. Doesn't matter. Okay, let's increase the number of the dimensions and create now a 3 by 6 by 2. This is a cube. Okay, so let's use reshape. In this case, we are going to create an array with using a range, so it will create a sequential number between 0 and the size that we want to, and the length of the number that we have. Because we have array 3 by 6 by 2, the length will be 3 by 6 by 2, okay? So now, and we say reshape this list. If we do this, is a list of consecutive integers, okay? So with reshape, we are telling, okay, now convert all this to an array of 3 by 6, 3 row, 6 column, and a theta dimension of 2. Okay? This is a cube of 3 by 6 by 2. Okay, let's try and print the output to see what happened. Okay, so okay, so what's the shape? We can see the shape. We shape the multiple array. That shape should show 3, 6, 2, which is the dimension of the array. Okay. How to access to any index is exactly the same way, but we add a new index. So this is the row, the column, and the index of the array in the cube. This will be because we have 2, this is the last one. Okay? So we'll show you in the array number 2 in the cube, the position 1, 5. We have two functions to stack arrays, which is a horizontal stack and vertical stack. This stack compresses array in one direction, horizontal or vertical. So let's try to do that and compress, just removing one dimension, okay? And stack the values.
Sebastian, will we see the flattening function of Numpy or method, or whatever it is?
I don't know what you mean. Flattening of.
There is something that has to do with doing flatting stuff. I don't know.
Flatting to flatting arrays.
Yeah, I don't know what it is.
But this is. Should we stack that?
No,
okay,
there is a function or something like this in Python that is, or one method probably. Yeah, it's not really.
Tipo per andare da una matrice a un array?
Non lo so esattamente, però l'ho incrociata più volte. Python flat. And the array flat.
There is no.
There is MD array flat.
Ah, no. But this is
it's
no, that is a type of
it's
matrix.
I found it several times.
But it's the type of the array, not a function.
It's an attribute, I think.
Attribute, but this is created something with another a function that is not flat. Probably.
It's not a function.
It's not a function.
But I was wondering.
I can have a look. I never use it that long. Okay, I can have a look.
Okay.
So, okay. Let's use mask. How to use mask? in array. Let's say that we have some numbers, but we don't want to operate with some of them. So we want to map some number, okay? To do that, we create this new matrix. Let's do that. We are going to learn how to mask some values. So create this matrix. Oh, it's flattened. Okay, it's flattened. Yeah, it's to collapse. It's the same like it's very. It collapses an array in one direction. I can show you it. Yeah. So as you can say, okay, collapsing rows or collapsing in columns. It's flattened. Flattened. Okay. So do we have the matrix? Or we have the matrix, the new matrix. So let's select only positive value. So we are going to create a mask saying, okay, mask is select all elements of that larger than 0. So this and print mask. So this is a Boolean matrix, okay, of false and true. Okay. If we multiply that mask by our array, show value 0 where those numbers that are lower or equal to 0, okay? And so show 0 where the max is false. If we want to show only the element selected, we use max as an index. Okay? That is the usual way is this second one, because we don't want to show 0 for element that we haven't selected. Okay, so if we type that mass as index, is going to show only the values larger than 0. Okay. We can do that also in a multidimensional array. Let's create now an array of 10 rows and 2 columns. Using a random generator number of Numpy, randint, so it's going to create a 10 by 2 random number between -10 and 20. This is a uniform distribution of integers. Okay. And now we want to set up 2 conditions, one for all the array. We want that the first column must be larger than 0, but less than 10 in the second column. How can we do that? So let's all have this matrix now, the 10 by 2. Okay, so if you print the matrix, you will see that our value is between -2 and 20, okay, in 2 columns. Now we want data with in the first column larger than 0, but data less than 10 in the second column. How we do that? So we set up a first condition relative to the first column and say, okay, all the rows first column select larger than 0. It creates true and false. Okay? And this one. For the second column, lower than 10. And we create a mask, which is the multiplication of both. and we give that mask as index, and we'll select and we'll show only the values that fulfill the condition. Note that 2 is a 10 by 2 matrix, but we are using here just an index that are a list of true and fail. But Python can handle that if it's a Boolean matrix. Doesn't matter if the size of the matrix is 10 by 2. We'll take this and we correlative. It converts the matrix of 10 by 2 to a single list, apply the condition, and give the output.
Then only the lines where both conditions are.
This is one condition, this is other,
Yeah.
and this is the joining of these two.
When you type that to mask,
Yes,
this is fourth line, last line.
This one?
There, yeah.
Okay.
When you type it, then the result is an array.
And is an array is no
Yeah,
the result
it's
it's not an array.
What is
They are the element that fulfill the condition, the both condition. Only the element. It's not an array.
Well, it is an array.
Okay.
That's why it's an array.
Oh, sorry, it's an array. Right, sorry, it's an array because it's an array. I mean, are the elements of the array, but it not need to. What is the shape? Could you make that to mask?
Let's see.
Shape. Mask. Sorry, shape. No, without the.
Okay,
Yeah.
right.
Only that shape. At the end,
Okay.
that shape
Okay.
is 6 by 2. Yeah, so it's.
No, my question is, in that two, you get as a result that two mask. As
Yeah.
a result, you have only the lines where both conditions.
Is
are
the
masked.
array? No, actually, what you're saying is the array removed the element that don't fulfill the condition.
Okay, yeah, that's
Okay,
that's-
because now you obtain a different right side.
yeah.
So it has removed the rows and the columns that are not within the condition.
Yeah,
Okay?
Yeah, that's it.
Okay, another way of creating mask. Now, in the previous example, we remove the elements that doesn't fulfill a condition. But what if we want only to mask but keep there? Okay, just in case we don't, we want to unmask again. Okay, so for do that we are going to use mask MA is a procedure of Numpy to mask array. So let's create the first array 1, 2, 3, minus 1, and 5. Okay, yeah. Good. Arrays created. Okay. And now we will mask the array using the code, the function ma, mask array. So here we give the array that we want to mask, which is this one that we have already created. And what is the mask? We will use 0, it means doesn't mask, and 1, you should mask this number, okay? So we say, because in this way we are going to mask only this thing, only minus 1 element, right? No mask, no mask, no mask, mask, and no mask. Let's print mx, And now we can sum the elements of the masked array. So it's going to sum all the elements that are not masked.
Cioè l'elemento that is masked is the one with 1.
Yes.
With the index.
This is the masked. 1 means masked. Okay? So if you print mx, you will see in the position of the masked element something that is hiding the element. Okay? So if we want to return to our masked array, we use no mask. Okay? We have to say it this way. We want to unmask the element, all the elements that are masked here, and don't touch the other element. We use this method, mask, mx mask equal ma no mask. So we are telling to the mask of mx, of this array, not to be masked. Okay, does it work? Work? No mask? So you can print mx again and see the unmasked, the -1 should be there. Is that right?
Yeah. Can you go back? Yes.
Mm-hmm. Relax, fine. No, you should print mx. Print mx. Now, it's unmasked. Okay?
Okay.
No,
It's
that's the
zero
mask.
4, okay.
If I have an array with number and string, I
The
can
same.
use this command to eliminate the string and make the operation of
Yeah.
number.
Yeah. You can say this element is alpha. Alpha means it's a string. So you can set up a condition to eliminate this. This is not the best way because this doesn't eliminate it, just mask. With the other Boolean, you can say is alpha and give you where are the string and then negate that and just use as an index and will eliminate the strings. Okay?
In that case, is it definitively eliminated?
Yes, in this case, it's definitive, but I mean, it doesn't touch the array that you are working. Just print out a not different one, but the original is not touched. Okay? It's like this. We can use you can make sure here. So the thing is that you have to be careful here because this is all string, okay? Remember? So there is a way just you have to convert to number here, right? To detect which is the string, because if you ask which is string here, all of them is string because it's measured. Okay, let's go structure array. This is interesting to read files with mixtures of strings and numbers, whatever, no? Combination. So let's first, to see how it works before read some complicated files, let's create a new Numpy array that is called galaxies. So So it's create in this way. So remember this create an array of zeros or full with zeros of 5 elements. Okay? And with each element will be associated different types. So for each name of a galaxy, we have called this name, but we can call it whatever we want. Okay, but this is, remember the dictionary. This is a keyword, and each keyword of name, it will contain the name itself, an order, which is the order in the list that we are creating in the array, the type of galaxy, and magnitude. And the important thing here is this keyword, which is format, and we are telling each one of this type what type of that data is. So this is string of 16 character, 16 characters. So when we type the name galaxies, this array will expect for the name a string of 16 characters. If it's less, it's going to fill up with 0, with empty space. Order is an integer of 4. This type is a string of 10, of length 10, and magnitude will be a float of 8. Okay? These are the usual data types in other language, like Fortran or like that. Let's type the galaxies now. Let's create this and type galaxy and see what is the output. Should be should show 5 elements because of zeros, because we say that we are going to create 5 galaxies with the entrance with no content. There.
Maybe because
the
U
is okay. U is capital.
Okay,
Capital.
just
Capital. But it's not only that.
Sì, 5 revise, però neanche capito. Sono 5 revise.
No, is a comma.
Sì, c'è delle cose che sono delle stringhe. Però io ho fatto già questo, non è successo niente.
Or something. This is the word closet, I think. You have 2. Yeah, this is closer to 3.
Okay.
Right.
maybe this is
Name,
not
what you name. Separate, okay. I don't know if, wait, it should be in this line. Could you? Okay. Yeah. Separate. Okay, do that, yeah. So it's working. The type, which is set up the type. Okay. Now.
Oh, okay, I see.
Why Numpy 0, Sebastian?
Come?
Why you have to write Numpy 0?
No, here because I have imported like NP, but there in the example is imported everything, so you don't have to type. But here I have imported NP. This is how it's defined. As you can see, it's the same like that. And print. Show this thing, okay? Always 0. So that means that is, okay? 1, 2, 3, 4, 5 tuples, because we say create 5, okay, there. And with empty, here we define this is a string, this is an integer, this is a string, and this is a float, as you can see. Okay, so it has created a structured array with the types that we have defined here. The format, these are the type. The type should have 2 keyword names and format. And name, whatever we want to say, and format, the format that we have to set up for each name. Okay? Now we can create the contents. For the name, we create 5 names. For the types, we can, of the galaxy, type of the galaxy, we create 5 names of type of galaxy, and the magnitude, because we is expecting floats, magnitude in float, and for the order, which is only the order in the list, 5 integers in this case. That can be typed directly, like in a list, between 1 or 5, or using range between 0 and 4. So it doesn't matter. So we create that, and now it's very easy to assign each element to galaxies, just calling in this way. Name, type, magnitude, and order, which are the names that we have defined here in names. Okay? This is like a dictionary, actually it's a type of dictionary. So we set up for name, those are the names. Type, this is the type of galaxy, magnitude, the magnitude, and the order, the list within.
If I want the 2 different conditions are satisfied, I can ask magnitude
yes.
Less than 9 and b minus b color look greater
yes.
than something,
yes.
and then the
yes.
different. And the not is
minus or the tilde. Tilde is the usual way.
So it's
tilde and the condition.
okay.
It's
It's not
negate.
an exclamation mark, no.
No. That's what is deprecated. It was before, but now it's deprecated. Probably going to actually no. The exclamation for comparison. I mean, some time ago was exclamation not equal, was exclamation equal.
Yeah.
And now is tilde equal.
Yeah, tilde is the negation.
Negation.
In any case, okay.
In any case, now exclamation equal accept yet, but it's deprecated. Is going to be removed in a.
If I want it to be equal to 9, I should use equal.
Equal, double equal, because it's not. It's a significant.
And if it is a string, I want it equal.
Exactly the same.
It's equal, but then the string goes in the.
Yes,
condition.
always. Okay. Do we have the the galaxy structure array filled with data. So now we can say, okay, what are all the names of in the galaxy? Just call in this way, name, print galaxy's name or type of order, whatever. And we can make conditions. Only show magnitude, galaxy magnitude less than 9, the names of the galaxies that fulfill this criteria. Okay? In this way. Very powerful. Is it clear? Any doubt? Okay.
No, excuse me. The last row.
The last.
Galaxies.
This is condition. Let's say that
Yes.
now we have everything filled up. Okay. And now we want to know what are the name of those galaxies with magnitude less than 9. So we say galaxies here, the output will be this. What is within here is an array of Boolean array. True, false.
Okay.
And here is the name. We want the name. If we want, for example, the type, just write type here. It's going to look for all the galaxies that fulfill this condition, and it's going to type whatever we want here.
Okay.
In this case, name, but could be any.
Yeah.
Okay? Matrix operation.
Why don't we stop here and start?
I think so.
That,
Okay, yes. Let's stop here and let's go to
okay.
Ranzo.
And then
And then we start again at 2 something and
To something?
Yeah.
To help us.
Oh, for me 2 is okay, but I don't know the others.
I will need a little bit.
Yeah, okay, so okay, so 2 and a quarter.
2 and a quarter, yes, so we can finish it. 2 and a quarter.
Too fasting.